Okay, in this problem we are asked to go back and look at the Nielson problem on the average number of hours per week within the 8 to 11 p.m. time period that the people were watching television. And if you remember, the confidence interval there is 7.34 hours to 9.66 hours. The margin of error was calculated as 1.16 hours. And what we're asked to do is to find the sample size so that if we sample the population with that number, we will get a confidence interval, or a margin of error, I should say, within 30 minutes of the population average, or 0.5 hours. So I want to be a 30-minute, I want to have a 30-minute margin of error, which is equivalent to 0.5 hours. So I want my margin of error to be 0.5 hours. So what sample size will do that? So x bar plus or minus, what we have is 1.96 for our z value. Still want 95% confidence. We have sigma, or at least a very good estimate of it, and we're asked for what sample size do we need so that that margin of error calculation will not be 1.16, but it will be 0.5. So basically, I'm saying that I want to make 1.96 times 3.5 over the square root of n equal to 0.5. What value of n does that? Well, algebraically, I've got to solve for n. So in solving for n, I've just got to get n on one side by itself. And let's see, I'm going to multiply both sides by square root of n and divide both sides by 0.5. And then I'm going to square both sides. So I have 1.96 times 3.5 over 0.5 squared equal to n. And doing that calculation, n is 188.24. So just to make sure we have the 95% confidence interval, we always round up. So the answer would be 189. Now the book actually gives you a formula to do this, so you can just plug into the formula. If you look at the confidence interval, x bar plus or minus z alpha over 2, sigma over the square root of n, my desired margin of error, we'll call it E, is the sigma over the square root of n times the z value, and then just solving for n. So multiply both sides by the square root of n and divide both sides by E. I'll have the square root of n is equal to z alpha over 2 sigma over E, and then n is that value squared and the book presents the formula using some exponent properties. So using the formula, I would have just put in, since I have 95% confidence, I'd put in the 1.96. My population standard deviation is 3.5. And my desired margin of error was 0.5. And that comes out to 188.24, which we round up to 189. And that's probably how you're going to do it. You'll be given the formula in the book, and you'll just plug into the formula. So my formula here is n equal to the z alpha over 2 squared times sigma, the population standard deviation squared, over whatever the desired margin of error is, squared. So if I take this, going back to the problem here, if I take 189 as my sample size and go in and sample 189 households instead of the 35 that we originally sampled, I'm going to sample 189. Then whatever average I get, whatever x bar average I get from that sample, is going to be, in a sense, a better estimate of the population average because I'm using a larger sample. So it's going to have a tendency to be closer. Its margin of error will be within 30 minutes or 0.5 hours of the real population average, as opposed to 1.16 hours. So it'll cut the margin of error in more than half if I use a larger sample, which intuitively makes sense. The bigger sample, the more information, the better the estimate, the less error will be involved.